everybody. How's everybody doing? If you're having a good conference day, we're going to wrap this up in about 30 minutes, but for now, you're stuck with me. So, whenever you write code, you're essentially telling a story. Because every time we start a new project, that project becomes a representation of problems that we thought were worth solving at the time, becomes a representation of maybe our dreams or passions, things we want to exist, but they don't exist yet, so we set out to fix that. The code itself, the code that you write to build your project, it's a snapshot. It's a snapshot of the architecture that you like to use, the programming language that you've just learned or that you've mastered a while ago and you really enjoy using. It's really the whole culmination of everything that you find interesting, useful, and good at the time of building your project. And what's really cool is that if it's just you working on the project, the whole project becomes a representation of your development, your skill level. You can come back to it weeks later, months later, years later. You can probably know exactly what you were good at the time, what you were really bad at, what you liked at the time, what you disliked at the time. And even if at any point you decided to redo the project or to change significant portions of it, I hope you have Git to take you back in time and to retell that story of what you worked on. And I think it's really cool that we as developers can do that. Right? We don't think about it a lot. We don't consider ourselves storytellers, but really, we're telling stories all the time. But as your project grows, hopefully it does, by the way, if you have a project that you started on your own, I really hope that you get to the point where more people become part of your story. You bring in other people because it's too much work for just you. But then these people all start working on your code and they start telling their own stories. And now the storylines intertwine. And you need some kind of overarching idea or pattern to make sure that not everybody tells their own story and your code base basically ends up being the equivalent of all of us standing up right now and doing a presentation all at once at loud volume. That wouldn't work at all. We don't want our code bases to be like that. We want our code base to be coherent. We want our code base to be its own thing. And in every story, there can only be more or less one main character. Sure, maybe some movies have 2 or 3, but for my story here, there can only be one main character. And when you just start your project, it's just you working on a project. Maybe you have 1 or 2 friends, but typically what happens is that the couple people, or just yourself, that you work with, you all have the same skill level. You know exactly what your best friend knows, what their skills are, so you know how you can work on a code base together and how you can keep that coherent story. But as your project grows, you'll find that you or the couple people you work with stop being the main character. And then you'll learn that the story that you told with your codebase was never really about you at all. The codebase is a reflection of you and of the people that you worked with, but it's not that you are the main character of your codebase. You're just the author or the narrator of that story that your codebase is telling. Because if your codebase is not the main character, it becomes a mess. And it was always about the code. Even when it was a snapshot of your skills, of the things that you liked, the code was the story, the topic of the story, and the main character of the story. You never were. It's tempting, though, to keep the story being about you, to just go, hey, I'm really good at this. I'm going to use this in the code. And I really like that framework, so I'm going to add that. Oh, I love what they've done here. I'm going to put that in the code base, too. And it's all because you want it to. And the thing is, the code base is your main character. It needs its own story arc. So every time you add something, you should be asking, does adding this help develop the story of my code base? If you've ever come into an existing project, you probably looked at the code that you saw in there, and you may have thought, wow, what a mess. What happened here? It's horrible. And what's funny is that I feel like there's a skill level kind of thing. A junior developer will usually come in and go, oh my God, I don't get it. And then as they become more senior, there comes this point where they know a lot and they become really good at development, but they don't have that seasoning yet where they look at code and go, why is it that the code is written this way? So these are the people that will typically come in and go, oh my God, what a mess. And then you get the person in who's done coding for 15 or 20 years, and they go, well, it's a mess, but let's figure out why. Let's see if we can figure out the story of this code base and see how we got here so that we can decide where we go next. But at the same time, no matter your skill level, you're probably a really eager developer who's constantly learning, growing, evolving, getting better at what they do. And so when you have a new skill or you learn a new framework, you want to use that. You don't want to go and learn stuff only to go, oh, great, I know this now, I'm never going to use it. So it kind of makes sense that you're going to find places in the code base where you're going to say, hey, actually, I just learned this thing a couple days ago. It'd be a great fit for that. So how do we balance all that? Right? How do we balance wanting to learn, grow, apply new things, thinking things are a mess, thinking things should be better? And so that's why I wrote this talk called Responsibly Evolving Codebases. I'm Donny. I'm an iOS engineer by trade. I've done a lot of other things as well, probably been developing for about 18 years now. I've done many, many different kinds of projects. And in every project, I found reasons to start over. Right? I found reasons that other developers wanted to start over. And so Responsibly Evolving Codebase is only part of my talk. The other part is why we'd rather start over, because I think it's a really interesting thing that we see time and time again, that projects sort of grow, and then we want to start over, and they grow again, and we want to start over, until at some point they become so big that everybody goes, yeah, there's no way that we're ever going to start over, because this is way too much. If I had known everything I know now, 10 years ago, I think I'd have done pretty much everything I did up until like 20 minutes ago when I made my last commit differently. Because with time and experience comes knowledge, right? If you're not learning and not changing your opinions, not changing your thoughts, you're probably not really learning anything at all. And it's an essential part of growing as a developer, right? And you can't really grow or learn if you don't make mistakes. If we're doing the same thing over and over again because we feel like that works well, we're going to do the same thing for 10 years, you do have 10 years of experience, but you have 10 years of experience doing just one thing. And you're probably going to be really good at the one thing, but you could do a lot of things to be very broad in your knowledge. And so you're not growing as consistently if you're not making mistakes and not trying new things. You want to keep on doing that. And with that, again, means that you're going to be committing code that's not perfect. You're going to be committing code that's not going to work well, and you're going to be committing code that probably at some point should be refactored or actually changed. And that makes total sense, right? It makes total sense that we learn, that we grow, that we keep shipping stuff, and then we look back in a couple months and go, okay, actually, there's a way better way to achieve the exact same thing. So we're going to refactor or even rewrite that a little bit. What's interesting, though, is that as we learn, the kinds of problems that we can solve also change. Right? In the beginning, if you're a web developer, when you just learned web development, you were probably extremely excited to be able to make things move across the screen with only CSS, because you'd never seen anybody do that. You're the first person ever to do that in your mind. And you look at websites, and they all kind of do that, but not in the extreme ways that you maybe did. And then later on, you actually learn how to solve complicated problems, like making some generative AI talk to other services to build a really complicated system. You could have not have dreamed that 5 or 6 years ago that you would ever be able to do that. And so what's interesting about that is also that something that looks complicated and over-engineered to you today, a couple years from now, you've learned, you've grown, and these things are not so complicated anymore. I remember very distinctly that I once worked at a startup where we used Python for the backend, and it was a pretty complicated product. And the people working on that, the people in the team that did the backend and I was helping them out, were really Python veterans. I had exactly 1 month of experience in Python when they were like, oh yeah, come out and help us because we need extra hands, so go ahead and do that. And a lot of the code they wrote, I was just like, I can build iOS apps, I'm good at that. I can build websites, I'm pretty good at that, but Python? Terrible at that. Why is this so unreadable? Why did you even do that? This seems over-abstracted. And luckily, I work with people who would actually tell me, no, I know it looks over-abstracted, but here's the reasons, here's what we're actually solving, here's the problem that we had to solve, here's why. And what was essential about that was that these people took time to actually help me understand the problems. They knew that because they had grown and learned so much, and they had, I think one of them had 15 years of experience at some point, they knew that somebody with less experience is going to look at the exact same code with very different eyes. And they knew that they could either just let me figure it out, and I would probably refactor things here and there and make mistakes and do weird stuff, or what he decided to do was much better, teach me. Teach me what he knows so that I also grow and also learn. At the same time, that also showed me that sometimes complicated problems are complicated, and the solutions are also going to be complicated. So sometimes a complicated problem requires a complicated solution, and it's not a sign that the code's bad or should be rewritten or that it's in any way harmful. It probably does mean that if you have that code and your junior team member goes, I don't get it, that you're on the hook for explaining to them what it does because you want them to understand, you want them to grow. Here's an example of a problem that I solved not too long ago that started off simple and ended up being very complicated. This is Swift code for those who don't know it. And you don't really have to fully understand, but every property on that list that has @published written in front of it, when that changes, it's going to tell somebody else like, hey, this property changed. The thing is, though, that if you nest these things, that changing a property on an inner object does not bubble all the way up. Right? It's only when you assign something new to the variable. So the problem here was allow changes to the innermost object to bubble out to the outside. Now there's something called object will change on an object in Swift if it's an observable object, and that will basically send an event when any of the properties changes. Right? So if any property on a certain object change, object will change is going to tell me about that. So one way to solve this problem was to just make a list of every single property on every object and go, if any of all of that changes, tell me about it. Problem solved, easy. Everybody can read this, everybody can understand what this does. Even if you've never written Swift, I could explain this to you in probably 15 minutes, what this does, and you'd be able to get it. The problem with this code requires developers to remember that this list exists. It also requires them to remember that if they add new properties, they're going to have to update that list. That's error prone. It means that we need to actively monitor this thing all the time. It's really hard to read a list that long. Like this was an abbreviated version. The total number of properties was around 70 at a time, and it's currently around 80. So this thing grows, this thing changes, and it's long. It would never ever scale well. So the solution was to make a protocol and add a single property to every object that I was interested in called willUpdatePublisher. So let's get that set up, and the code looks like this. Now, I intend to keep this code up for about 15 seconds. I do not expect you to read it. I just hope that you can see that we're doing some weird things here. We're using something called reflection, which means that at runtime, we're inspecting which things are inside of this object so that we can see what these things are, and then sort of recursively go deeper and deeper into the hierarchy to figure out all the properties. This is pretty nasty, but it solves the problem in a way that is scalable and that's not very error prone. A couple of unit tests, I know it works perfectly fine. So is that harmful? Right? Am I changing the code base in a way that's going to cause problems down the line? And is this one of these things where somebody's going to say, hey, we should rewrite this? I can guarantee you that somebody's going to say that at some point. So how do we prevent that? How do we make sure that somebody who's a more junior developer who would maybe prefer the list because they get that, they could come up with that themselves, how can we convince them to actually not think that this is bad and understand this? And the solution to that is really to add documentation, right? We need to add a couple of documentation comments. Why did we solve the problem in this way? Why does this thing exist in the first place? We don't need to add comments like, and here's where we do the recursion. People can figure that out, but the why does this exist, and why did we think that this was the best solution at the time, makes it so that somebody can make a conscious decision later on whether or not to rewrite this code. And what you can see from that, if you're an experienced Swift developer, what I just showed you probably looks mostly stupid and not necessarily complicated. If you've never seen Swift before, this looks extremely complicated and you have no idea what it does. And so complexity and over-engineering look very different to people depending on their skill level. And I actually showed this code to a couple of people, and I showed it to a couple of junior/senior kind of developers who I mentor. And they were just like, oh, but there's like 10 other ways to do this, isn't there? I was like, probably 11? Yeah, definitely, there's other ways to do this. Yeah, we should do another way, I think. It's going to be better. It's like, why would any other way be better? And basically they all came back with, I just didn't understand reflection. I've never used it, I've never seen it. It's completely new to me, so I would prefer to read something that's not new. So again, documentation, a little bit of teaching, and then suddenly it's not new anymore and it's fine. I showed it to a couple more senior developers and they said, oh, that's clever. Stupid, but clever. Because reflection is not necessarily performant. And so I told them, well, the thing is, this is only done once in the entire app lifecycle, so I don't care that it's not super performant. And then they were like, well, kind of smart. It solves a real problem in a way that we can understand, that we can test, so perfectly fine. So coming back to rewrites, I loved rewriting things when I was at the beginning of my career. I would look at code and think, this is either super cool or I don't get it or whatever. I would just rebuild it from scratch. I think this code does X. Let's see if I can make other code that also does X. And usually it meant that all the parts that I thought were over-engineered, I would slowly but surely figure out that they were actually really important to the solution, because getting there without that was really hard. And because I've done that many times throughout probably my first 5 or 6 years of learning how to develop, I've learned my lesson. Rewriting things generally doesn't make things easier. It helps your understanding, but it's not always better for your code base. And as I already kind of mentioned, there's a little bit of a bell curve on your skill and confidence as a developer. I noticed it in myself. I noticed in others that I've worked with. I've heard similar stories from a lot of people. When you're new, you don't know what you're doing. So probably everything is hard and complicated, but it probably should be, because everybody is so much smarter than I am, so it makes total sense that I don't get a single thing in this code base. I'll just quietly watch other people work, kind of do my tickets, and hopefully pick up a thing or two in the process. But then you learn a couple things, you work with some people, and you get this huge confidence boost. You figure out that your skills matter. Maybe you even had a couple PRs where your senior developers were like, wow, this is really good, really smart. And so you feel like you know what you're doing, and you try and improve other people's code. Make a couple rewrites, maybe even go ahead and commit to main directly a couple times. And then you realize that the stuff you refactored really shouldn't have been refactored, because it was taking care of that one bug that somebody solved a couple years ago, but they just forgot to link the Jira ticket of why that thing existed, and you removed it, and it's a bug that only showed up for that one customer that actually paid a lot of money for your product. Now I have an angry customer, and somehow it slipped through pull request review. And so as you kind of experience that a couple times, you come back down and you go, actually, you know what? I know what I'm doing, but I should probably also hold off on being too eager to redo things. And I think it's also to do with, like I mentioned, how we learn. In order to learn, we love to reproduce things. If you want to learn how to draw or paint, you're not going to close your eyes and imagine something that doesn't exist. If you want to learn how to paint, you're going to set up a nice fruit ball on a table, put some pretty lighting on it. You're going to paint that. You're going to recreate something that exists. If you want to play music, you're going to listen to other people's music and recreate that before you start to write your own songs. So it really makes sense that if you want to learn how to code, you're going to redo things that already exist, probably in new and creative ways, because that's also a thing that we as developers love to do. And on top of that, even if we're not doing it to learn, we often feel like a rewrite is a clean slate. We can rebuild our code, and we can rebuild our understanding of the code. We can get rid of all that baggage. We can get rid of all the things that we didn't like about the code. Fortunately, this slate isn't always as clean as we'd like. If you're working on an SDK, for example, you probably have some public API that you need to keep running. Maybe you weren't happy with that, but you're going to have to keep that going. And it's not really the best way to fix mistakes. Already talked about that. So if we talk about complexity a little bit more, because that's really where this whole thing sort of is built on top of, And it's going to exist in our projects. The complexity is really what holds us back from doing a full rewrite, right? A real-world product is really complicated, and just rebuilding that from scratch, try to convince a manager that you're just not going to ship anything for 3 months because you need to put a hold on that complexity. We're going to rebuild that. If I were your manager, you would come to me with, we're going to rebuild this in 3 months. I would tell you I don't have 12 months for a rebuild. You would say, no, I said 3. I said, come on. We all know you're lying when you say 3 months. So how can we introduce complexity into a code base in a way that doesn't push us towards that rewrite all the time? Right? How can we get to a really complicated code base without feeling like we're doing something wrong all the time? Because complexity hides in many corners. And it's always a trade-off, right? Even when you're introducing something small like SwiftLint, if you're a Swift developer, or JSLint, or PEP8 if you're doing Python, or a very lightweight architecture that you maybe made up yourself and it only has 3 rules. It's still complexity. It's still something for other people to learn, to install, to understand. Right? I once introduced SwiftLint into a project, and suddenly the project wouldn't build anymore. And so someone's like, why can't I build anymore? I was like, well, that's because SwiftLint's telling you to not do this one thing, just change that one line of code as it asks. And they were like, I don't get it. It worked fine yesterday. Like, well, SwiftLint tells you, and I really had to explain that. And after that, of course, it was fine, but it was some complexity, some friction that we needed to resolve in the code base. If you're introducing bigger dependencies, like in an iOS project, the composable architecture, which is very similar to Redux in React, or if you're doing reactive programming, that's a very high base knowledge level for your code base. If you're not doing things vanilla, you're introducing a framework. Now somebody has to also learn that if they want to contribute. If you're using generics in a programming language that supports that, or if you're doing abstraction, or even if you're introducing code generation, where a lot of the code that runs in your project does not actually exist until build time, that's all complexity that people need to understand. And what really matters if you want to do this responsibly is that you can do that in a teachable way. If you're going to introduce architecture, try not to invent your own unless you absolutely have to. Find one that is widely used by a community that exists for your programming language or for your area of expertise. And if the community has sort of a popular architecture, use that instead of your own, if it fits your use case. Because then you can actually go ahead and add some comments, some documentation. You can have a little document up on your own community where you can say, hey, look, if you want to learn about how we do things, here's like 5 or 6 resources on just that. So go ahead and read that and you'll get exactly why we do things. So that makes it all very teachable and very easy to transfer the knowledge. And then there's complexity of project size. Right? If you're a newcomer in a project and you find out that it's enormous, that can be a really big barrier of entry. It can make it really hard for you to figure out where to start. And again, that's all about making it teachable again. Have a little document that says, this is the entry point of the application. This is a feature that changes a lot. This is a feature that existed for like 5 years. Not a single commit has been made. It's the core kind of the whole thing. But really, you don't need to touch that. Like if you're super bored and want to read something that was not touched for 5 years, go for it. But otherwise, stay far from that because you don't need to understand what that does just yet. Focus on these little bits. A document like that, even if it's just 2 paragraphs, can make a new joiner, regardless of skill level, extremely happy. And again, it will make them understand your code base better. It will make them make more valuable contributions. And it will reduce the likelihood that they eventually go, let's redo this. And making sure that your project is browsable and explorable, even when it's enormous, is a tough problem to have because sometimes things just get really big. Splitting things up into modules can really help as long as you keep that simple. In the world of iOS, we have this idea that comes from, I think, Airbnb, and they have a really big application, as you can imagine, and they have a really complicated setup. And for them, it makes sense, but a lot of people try to copy it. The idea is basically I have a module A and a module B, but these modules cannot know that they exist. So I have a module A, an interface for module B, interface for module A and a module A, and then a module B and an interface for that. And then I have an interface AB that tells them how they can talk to each other. People try to copy that when they're like a 5-person team. Probably not the thing you should be focusing on. Keep it simple. You're not Airbnb. You're a couple people. I'm sure you can communicate about what should be talking to each other. When you end up growing to the size of Airbnb, sure, do whatever you want to do. But making an already big project more complicated than it needs to be is not helping anybody, especially new joiners who won't be happy with that. And then there's also the thing with new and shiny. And this is again something that I did a lot when I was just learning how to code. I would see Apple's presentation for WWDC, and they would announce something new, and I'd be like, oh my God, this is the best. I would run to my project manager and go, can we drop support for, well, basically the current iOS version? And they would go, what? No, why? Well, because Apple just announced this thing, and it's really cool, and we should be using it. It's going to make all our code so much better. It's going to make everything easy. It's going to be perfect. Can we at least use it in like 6 months when it's officially released? Well, we can see where it ends up being. Like if people update fast enough, let's try that. And so I've once actually done this where I went in and tried it, and then I found out that really it was a horrible experience because it was not as good as WWDC made it look. It didn't work as well as I hoped it would. I spent a lot of time on it, and basically after probably a month, I was like, I'm just going to throw away this whole branch and tell my project manager that this one thing is not happening. We're going to do it in like 4 years when it's stable, when it's been proven, when other people wrote about it, because I'm not the first one to make this mistake. And I think this is true for pretty much any framework or technology that you're on. Another thing that I think you should not do, which is tempting sometimes, is optimize for things you don't need. I think we all know about this. If you anticipate that 2 or 3 years from now your project might have to support 15 million simultaneous users, how about you get to 1 million first, right? Maybe try that. Also, tech debt is real. If you're growing your code base, you're going to take on tech debt. Deadlines are real, right? Project managers want you to deliver things, so you're going to, at some point, cut corners. It's inevitable. And your tech debt, it doesn't just go away by ignoring it. And rewriting is not paying your debt, right? Because what happens when, let's say you declare tech bankruptcy, right? I have so much debt, I can no longer sustain this. I'm just going to restart because this whole thing is messed up. You're going to rewrite, but at the same time, your manager is going to be breathing down your neck. Deliver, deliver, deliver. Guess what you're going to do? Cut corners, take on new tech debt. Not going to be good. So who's responsible for all this? Because I just said a lot of like rules, like document, keep things simple and all these things. Who keeps us in check and make sure we don't go overboard? Well, you do, right? If you're a more senior developer, you're the one to make sure that your junior developers can learn from you. You're the one that needs to make sure that things are documented. You don't need some manager to go document, document, document. It should be part of what you do. It should be part of what you want to do. You should want your junior developers to learn and grow and be better at what they do. Because in the end, if you train your junior developers, they're going to make your life easier too, so why not? And of course, it's all a process in the end, right? We can all try to do the perfect thing all the time. Deadlines are real, mistakes get made, right? We can't all do everything perfectly. So as long as we're trying to get better at what we do, I think we're in a really good spot. And I think by trying to follow the rule of making things accessible, documented, easy to read, easy to understand, we're going to find that rewriting probably is not going to be proposed as often. And I think we can find that we can evolve our code bases in a natural and sensible way. So, in summary, when we grow our code base, we often know of a rough direction where we're going, but we never know exactly where we're headed. Our skill level impacts our perception of code. If we're very junior, something might look really complicated. If we're more seasoned, we can probably deal with the most complicated code and still kind of make sense of it. Don't optimize for a team that you don't have yet, or for a problem you don't have yet, but also don't really ignore where you're going. If you know that this thing is going to grow, anticipate, but don't optimize for it just yet. Make sure that when you have new team members, that you onboard them properly. Don't just show them your code real quickly. tell them which parts are interesting, which parts are probably for a later moment. Make sure that you document where you can. Make sure that everybody kind of knows where to go. And if you can, refactor things, make small changes, incremental changes, and don't do a full rewrite. Because in the end, the tech debt that you're hoping to get rid of, you're just going to introduce it in another place. Thank you very much, and have a great rest of the conference.